So far, we've been looking at measures of central tendency and variability for ungrouped data. Now we're going to look at measures of central tendency and variability for group data. We're going to look at the mean, median, and mode, and the variance and the standard deviation. Starting with the mean of group data, the mean is a weighted average of class midpoints, where the class frequencies are the weights. And here is the formula for the grouped data. That will be equals in there. That should have an equals. It didn't come up on the type script. So what it is it's the sum of the frequencies multiplied by the midpoints of each class, divided by capital N if it's a population, or I'm going to put down here small n, where n is the total frequencies or the total number of observations in the data set. Okay, so if we're talking about a population, that's capital N. If we're describing a sample, it's going to be lowercase n. Okay, so but it'll come out the same given an example. We're going to look at an example in just a moment. The median of group data. Here is the formula where L is the lower endpoint of the class containing the median. Okay, so just the regular median of ungrouped data. W is the width of the class containing the median of the ungrouped data. And then F is the frequency of the class containing the median. And capital F is the cumulative frequency of classes preceding the class containing the median. Key word here is preceding, not including the class containing the median. And N is the total frequencies or the total number of data values, which can also be lowercase n if it's a sample. Okay, so we're going to look at an example here. We're looking at a table that's showing the frequency distribution for the number of employees per company. What is the mean and median? So that would be the grouped mean for the median for the groups. So we have here 5 classes, 1, 2, 3, 4, 5. So in the first class interval, we have 0 to under 20 employees, where there were 32 companies. Then we have 20 to under 40 employees, where we have 16 companies. 40 to under 60 employees, there were 13 companies. 60 to under 80, 10 companies. 80 to under 100 employees, 19 companies. Okay, so if we want to get, now let's assume this is a population. So we will take the sum. So the total number of observations in this data set, we add them all up, add the frequency. So total frequencies comes to 90. So you can check that. And we then want to know what is the midpoint of each class. So to get the midpoint, M, capital M, 20 subtract 0, divide by 2. The midpoint for the first class is 10. The next one is 40, subtract 20, divide by 2 is going to give us 30. The next one is 60, subtract 40, divide by 2 is going to give us 50, and so on. So this will be 70, and then finally 90. Those are the midpoints of each class. If we multiply this column by this column, we will get the third column here. So we have 32 multiplied by 10, we're going to get 320. Then we take for the second class, 16 times 30, 480. And then 13 times 50, 650. 10 times 70 is going to give us 700. 19 times 90 is 1,710. Let's add all those up because we want the sum of the frequencies for each class times the midpoint of each class, and the sum of all those is 3,860. So the mean of group data is mu of grouped, right? Because we're looking here at a population, so we'll use mu. If it was a sample, we would do x bar of the grouped, right? So here it's the mu. So mean of the group data is going to be the sum of the frequencies times the midpoints in the numerator divided by the total frequencies, or capital N, in the denominator. So we'll put those numbers in the numerator. 3,860 divided by 90 gives us 42.89, and that will be the mean of the group data. So that's 42.89 employees. To find the median of the group data, so the median of the group data is going to use the formula, and we can go L plus N divide by 2. Again, if this was a sample, that would be a lowercase n. Subtract F. Make sure you subtract F, and then divide the whole thing by F, and then multiply by the width, W. So we need to find what the median is of the ungrouped data. So we want to go, well, we can use our position formula. Remember, n plus 1 divided by 2. That'll give us the position of the ordered array, the position of the median for the ordered array. So ordered meaning you would start with class 1, and you go, okay, there's 90. Actually, in this case, we would have capital N because we're population. So 90 plus 1 divided by 2 is 45.5. So the median would be the average of the 45th and the 46th observation. Are they in interval 1? They're not in class interval 1 because those are only the first 32. So they're not there. What about the second one? Well, the second one, you would want to add 32 plus 16, and that gives you 48. So right there, we know that the median is going to be in this class because the 45th and the 46th observation are in the second class. So that's the class containing the median. Okay, so we can continue. So L is defined as the lower endpoint of the class containing the median. In this case, 20, right? That's the lower endpoint, 20. And N, capital N, is 90, right? Divide by 2. Subtract capital F, which is the frequency of the class, the capital F is the cumulative frequency of classes prior. There's only one class prior, and that is the class 1, so that'll be 32. Divide by lowercase f, which is the frequency of the class containing the median, that's going to be 16, right? And then multiply that by the width. So W is the width of the class containing the median. That's going to be the width between 20 and 40. If you go from 20 to 40, that's going to be 20. So you can simplify this expression to make it easier and to less risk of making a mechanical error when you plug it into the calculator. And so you can simplify it more, and you should get 36.25. So that is the median of the group data. So 36.25 employees. Okay, so looking on to the variance and the standard deviation, since it's a population, you would want to use these formulas to calculate the variance first, and then if you need the standard deviation, just take the square root of the variance, much more simpler. And if it's a sample, the only difference is you would divide by n minus 1 instead of divide by the total. So you want to be careful with that. It's the only difference. All right.